All right, so in this problem, I'm going to answer the question with regard to the domain of this function. What we're asked to find the domain of the function f of x, where f of x is equal to the natural logarithm of x squared plus 16, and to write our answer in interval notation. Okay, so what we want to, when we have logarithms, what we need to remember is that the argument of the logarithm, that's the bit inside the parentheses, in this case x squared plus 16, must always be positive in order for this to be defined. So x squared plus 16 must be greater than 0. All right, so that's my condition, if you like. X squared plus 16 must be greater than 0. All right, for any the values of x which will satisfy this condition are the values of x for which the function will be defined. So all we really need to do is to solve this, and there's a couple of ways we go about thinking about this. Well, we can look at x squared plus 16 must be positive. Well, we know that plus 16 is positive. All right, so the question then becomes, well, where would x squared plus 16, for what values of x would that be less than or equal to 0? Well, x squared is going to be always positive for any values of x other than 0. For if x is 0, then x squared will be 0. But even if x is 0, x squared plus 16 would be 0 plus 16. That will still be positive. And then for any other values of x other than 0, x squared will be positive. If I consider x equal 5, well then x squared will be 25. But if I consider x equals negative 5, well then x squared will still be positive 25. And so x squared will always be greater than or equal to 0. If I add a 16 plus 16, then x squared plus 16 taken together will always be greater than 0. And so I can input any value of x I like into this equation, and it will always be greater than 0. If I was to try to solve it, x squared plus 16 greater than 0, I would subtract 16 to the other side. I would have x squared greater than negative 16, and taking the square root of that, then I would have the square root of a negative number. So I would have x greater than the square root of negative 16. I have the square root of a negative number, which is not real, and so you can see that there are no values of x. Indeed, that sort of confirms that there are no values of x that I can put in here that would satisfy this equation. There are no real values, we might say. And so the answer is that the domain of this function, the domain in interval notation, is negative infinity to positive infinity. You can put in any values of x that you choose, and this x squared plus 16 will always be greater than 0, and therefore the function, the natural ln of x squared plus 16, will be defined for all values of x. Just by way of contrast, if we were to contrast this with x squared minus 16, if my function had been f of x equals ln of x squared minus 16, and if I were now asked to find the domain of this function, well, it would be quite different. Again, we go through the same argument. The argument of the function x squared minus 16 must be greater than 0. So x squared minus 16 must be greater than 0. All right, well, I can try and solve this. And if I solve this, what I end up with is that, well, therefore x squared must be greater than 16. And taking the square root of both sides, being careful here because I'm going to have a plus and a minus, that would mean that x must be greater than the square root of 16, and x must be less than minus the square root of 16. And so here I have x must be greater than the square root of 16 is 4, so if x must be greater than 4, or x must be less than minus 4. So x must be greater than 4, or x must be less than minus 4. And those are the values here. We would write that maybe in interval notation if you like. You could write this as, so any values from negative infinity to negative 4. So that is negative infinity to negative 4. And then union, nothing, I cannot use -4. I cannot use anything between -4 and 4. Any values of x in there are out. But I can use greater than 4. So that is 4 to infinity, 4 and greater. And so negative infinity to negative 4, union 4 to infinity. Those are the values of x that I can use that would define this particular function, right? So just by way of contrasting with the previous problem, if you change that x squared plus 16 to x squared minus 16, then it's very, very different. I could also, just to give you a sense of what it looks like graphically, if I was to graph x squared plus 16 on Desmos, and here it is right here, x squared plus 16, you notice that the function is only above the x-axis. The origin 0 is down here, and so the function is the function x squared shifted vertically up 16 places, and so it is positive for all values of x. It never goes below the x-axis. There are no negative values. There's no value of x that you can put in that would make your function negative. Contrast that with x squared minus 16, which is going to be down here. And sure enough, the two roots of my equation are -4, 4. So those are the values. X is -4 and x is 4. Those are the two values for which x squared minus 16 is equal to 0. And then any values between -4 and 4, the function x squared minus 16, or that value x squared minus 16 will be negative. And so those are out. So I need to just be to the left of -4 and to the right of +4. And that's the difference between these two functions right here. So hopefully that gives you a sense of why, if I go back to my problem, why the domain of f of x equals ln of x squared plus 16 is all values of x. So you can put in any value, any real value of x that you choose, and x squared plus 16 will always be positive, and therefore the natural logarithm of x squared plus 16 will always be defined.